Okay, hello everyone. So we have already covered motion of charged particle in magnetic field when velocity and magnetic field both are perpendicular to each other. We have derived the time period, we have derived the radius, and we've also derived how the path will be circular in nature. And now there are two more important cases like what will happen if V and B are not perpendicular and what will happen when V and B are parallel. So this lecture contains very important derivation of this chapter. So please note it down. Okay. So let's move forward. So suppose that V and B are not perpendicular to each other. Suppose between V and B there is an angle theta. Suppose between V, so this is velocity and this is magnetic field and there is angle theta between them. So this velocity will have two components now. V cos theta that will be parallel to the magnetic field. V sin theta that will be perpendicular to the magnetic field. Now we already know that if velocity is perpendicular to magnetic field, then it will result in a circular motion. So in this case, there will be circular motion due to V sin theta and the particle will move forward due to V cos theta. So what will happen? There will be circular motion due to this component. So the particle will be in circular motion due to V sin theta and the particle will move forward due to V cos theta. So what kind of path will be there if this kind of motion is there? So the path will be helical in nature. So the particle will be in circular motion also and the particle will also move forward. So you have to remember when velocity and magnetic field are perpendicular, then the path is circular in nature. But when velocity and magnetic field are not perpendicular and there is an angle theta, then the path will be helical. The reason being the particle will move forward also and the particle will be in circular motion also. Okay, so you have to remember this thing. But remember that magnetic field can never change the magnitude of velocity. Magnetic field can only change the direction of velocity because magnetic field is perpendicular to velocity. You have to remember this concept. So if V and B are not perpendicular and there is an angle theta, then the path will be helical as you can see in the animation or in this video. Now how to derive radius? So in this case the force due to magnetic field will be Q VB sine theta because now there is angle theta between V and B and the particle will be in circular motion due to V sine theta. So you have to take the component which is responsible for circular motion, not V. So centripetal force will be mv square by r. So in the place of v, I put v sin theta square. So equalizing both the forces, so qvb sin theta will be equal to mv sin theta square by r. So 1v sin theta will get cancelled out and radius will be mv sin theta by qb. Now if you'll see, if you put theta equal to pi by 2, then we'll get the same formula that we have derived yesterday. That is mv by qb. So you have to remember this formula for radius. So radius depends on angle. Remember this thing that radius depends on angle and the formula for radius will be mv sin theta by qb. So the required centripetal force is being provided by magnetic force. Okay, so if the particle is in circular motion, then what will be the time period? How much time will it take to complete one revolution? So radius we have already derived. Now particle is in circular motion due to v sin theta. Now velocity is distance by time. So velocity is v sin theta. In complete cycle, it will travel 2 pi r divided by time period. So putting value of r here, time period comes out to be 2 pi m by qb and frequency will come out to be qb by 2 pi m because frequency is reciprocal of time period. Now, if you'll see the formula, time period is independent of angle. So whether the angle is 90 degree or angle between 0 and 90, the time period will be 2 pi m by qb and frequency will be qb by 2 pi m. These two formulas were very important. If you'll see, the time period is independent of velocity and radius. This is a very important concept because in magnetic field, when the particle is moving in circular motion or helical motion, the time period of one revolution does not depend on velocity and radius. It's ironical because the time period to move in circle is not depending on radius. It's not depending on velocity. It's very ironical, but this formula is very important for an important device called cyclotron. Okay. Now let's discuss pitch. Pitch is basically distance traveled by charge in one revolution. Now the particle is in helical motion, so it is in circular motion also, and it is moving forward also. So 1 revolution means this distance is called pitch. So how much the particle has traveled in 1 revolution? Now the particle is moving in forward direction due to v cos theta, and time period for 1 revolution is 2 pi m by qb. So velocity is displacement by time, displacement will be velocity into time. So pitch comes out to be 2 pi m v cos theta divided by qb. This is a very important derivation, you have to remember this. Okay, and the last case is what will be the type of motion when V and B are parallel. So if V and B are parallel or anti-parallel, the formula for force is QVB sine theta, and putting theta equal to 0, force will be 0. So the particle will pass undeflected. Undeflected means the magnetic field cannot apply any force on charged particle. So the particle, if it's traveling in a straight line, it will just pass through the magnetic field. There will be no deflection in particle. So we have three cases now. If V and B are perpendicular, circular motion. If there is angle theta between V and B, helical. If the angle is 0, there will be no deflection. The answer will be straight line. So the synopsis is here. So if theta is 90, circular path, radius mv by qb, time period 2 pi m by qb. If theta is between 0 degree and 90 degree, path will be helical. Radius will be mv sin theta by qb, time period will be same. If theta is 0 degree, the particle will pass undeflected straight line. Radius and time period are not applicable. Okay, so we have covered the topic motion of a charged particle in magnetic field. You to write down all the derivation and the formula, and then I'll send you a quiz maybe today or tomorrow. You to submit that quiz for motion of charged particle. If you have any doubt, you can send me. Okay.